Hello, everyone, and welcome to another Orland Park Public Library virtual program. Today we have our Earth Day program, and for our Earth Day program, we are joined with Nick Virgil, a park ranger from Denali National Park, and he will be talking about how climate change is affecting the Arctic and its impact on Alaska's permafrost. And the program today is called Climate Change and Alaska's Glaciers. So thank you all once again for coming out for Earth Day. And I'm glad we have a program for you guys this year. And without further ado, here's Nick.
Thank you. It's a pleasure to be here. I have been looking forward to this presentation to share with you folks for quite some time. As presented, I'm Nick Virgil. I work for Denali National Park as a park ranger, and we're going to be discussing basically the hidden ice of Alaska. But first and foremost, I want to just give a land acknowledgement on where we are up here in Alaska. So I'm calling from the center of Alaska, which is known as the Tanana peoples. There's also the Otna and the Denana. And those are going to be the areas we'll be discussing mostly. So Alaska is a very diverse state with Native Alaskans having tens of thousands of years of history here in connection with the landscape as well as the ice. So I'm located in the center in Fairbanks, and we're going to get more into that here in a minute. But first, before I go any further, has anyone heard the breaking news about what's happening in Alaska and glaciers right now? And feel free to write that down in the chats if you've heard about something in the news. I saw it on CNN the other day.
For the few who came in after I explained this, the chat is disabled, but the Q&A is not. So if you wanted to say anything, please put in the Q&A and we will read them out.
Thank you. So I guess you guys haven't heard the breaking news. That's okay. That's why I'm here. So we have an incredibly large glacier up here in Alaska that has decided to basically start moving. And as we know, glaciers do move, right? It's part of their life and livelihoods. But what's really unusual about what's going on right now is that there's this glacier called the Muldrow. So in the center of the screen, there's a photo. It has several different glaciers, but the Muldrow is the largest on that picture. And it's born at 18,000 feet between the two peaks of Denali, which is the tallest mountain on our continent. And it travels meandering through the mountains, as you can see, and then spills kind of out. That is this massive curve to the north just before Anderson Pass. And where you see at the tip of that curve is this light dotted blue line. That's the terminus or where the glacier stopped back in the 1950s when it did this incredible event called a surge. So the Muldrow is what we classify as a surging glacier. It's extremely rare for glaciers to do such an activity. There's only a handful in the state of Alaska. And the Muldrow is over 34 miles long. So I believe that distance would be from if you were in Chicago and you wanted to go to Michigan City across the lake, that's 34 miles. So the next time you're in Chicago or Michigan City and you look across the lake and you see either one, that is the length of this glacier, and it is moving fast. It started movement back in March at a rapid rate of, and we started recording anywhere from 3 feet to just the other day, it was recorded 100 feet of movement. Back in the 1950s, it moved a total of 5 miles in a single jaunt in about over 8-month period. So every 50 years or so, the glacier does have a surge event. This year, we're really excited to see where it goes and when does it stop. Right now, we have several teams of researchers out there on the glacier and monitoring it closely. At the end of this presentation, I actually have a link, a QR code that you can scan, and it'll show you up-to-date information on this incredible geological event that is occurring right now on our planet. So, but as you know, we're not just going to talk about the Muldrow, we're going to talk about ice in general throughout Alaska. We're constantly inundated with images when we think of glaciers of these beautiful, vibrant, clear, good-looking ice, when in reality, there's a wide variety of ice here in the state, in particular what's beneath our feet. So this image is going to show you basically what the mapped out areas of permafrost are. So before I get even talking about permafrost, let's move on to simply like, this is the imagery that we're greeted with when we see glaciers up in Alaska and anywhere else in the world. This photo was taken at the Kenai Fjords, which has what's called our tidal glaciers. So these are glaciers that feed into the ocean from the Harding ice field. And much of Alaska is protected. A lot of these glaciers have protections themselves, and therefore don't necessarily come under any kind of mining constrictions or anything like that. They're all public access for the most part, but they do reside in some pretty harsh terrain. So it's sometimes difficult to get to glaciers, but permafrost, as we'll discuss later, is a little bit easier to get to. So in a massive state, you know, Alaska is incredibly huge. We're just going to focus really on one particular area, and that's going to be Denali National Park. We're going to be talking about what's happening in this park when it comes to climate change and permafrost, how that's having an impact on the humans that live in and around the park, and then how that's having an impact on you in Illinois or Indiana, where you're from. Although you're over 3,400 miles away, there is actually some very relevant information that's occurring right now. And hopefully I'll get a chance to share that with you and answer your questions. But to put this park in scale, it's a little over 6 million acres, which is equivalent to about 2 sizes of Cook County. About half of the park itself has permafrost, mostly in the northern area. And then about 15% of the park is ice covered with glaciers and permanent snowpack. In the park itself is primarily only one access, and that's going to be the Denali Road. It's a 92-mile road that was put in place back in the 1930s by the Alaskan Road Commission. And it is a critical infrastructure for a lot of businesses and for a lot of people to experience one of the most premier wilderness areas on our planet. And we're going to come back to this road here in a minute. There's some things going on there that are having some major impacts on that industry, which just the Denali Road alone brings in roughly 600,000 visitors a year, which is equivalent to hundreds of millions of dollars for local economies and such. So first, let's kind of set the scene. You know, we talk about Alaska. It has a wide variety of history and culture, and even some recent history, including there's a particular book called Into the Wild, and I guess a lot of people have read this. Then they made a movie about it, and this is the bus that was filmed in the movie. And the original bus actually was removed from the wilderness due to some hazardous conditions for the area. And part of that actually is related to melting permafrost, and glaciers have made it so hazardous that we decided that it just wasn't feasible to keep it there for people wanting to visit. So the state of Alaska decided to remove the bus, but you can still visit the tour one, it's still there. And a lot of people come up to see this bus and see other things, in particular the wildlife. You know, we have caribou here on the left, moose on the right. You know, these are great neighbors. They've been living off this land for tens of thousands of years. They have an incredible fossil record as well. And what's really incredible is that when these animals die, they get covered into the permafrost and therefore become part of that geological record. So we can look at how they've evolved over the last eons. And another aspect, of course, are bears. So we have plenty of grizzly bears that love this lush terrain that we have here. It's a grizzly bear mecca. We're actually going to talk a little bit about grizzly bears later on. There's some active research that we've actually gotten visitors involved in. And it involves scat, which is basically bear poop. But the number one reason why this park was really created was simply for these critters. These are Dall sheep, and they're gallivanting on the side of this road that's in the park itself. So a lot of visitors get really up and close and personal with these critters. They love living on these very steep terrains, which is what you're seeing right here in the foreground. And if you look off to the left, ooh, my screen's getting dark. Don't know what that's all about. Give me one moment, folks. All right. So the Dall sheep, they reside on these steep terrain areas. And again, take a look at this road. We're going to come back to it. If you notice on the left side, there's some, looks like some gray sliding rocks. There's something going on underneath those rocks that we're going to talk about here in a minute. But as you can see, there's a wide variety of wildlife. This is called a pika, or a pika for some folks. It has a really unique call, and I kind of want to play you the sound of that pika. Yeah, so what's interesting about that pika is it's actively being studied right now by the Park Service, as well as several other agencies and groups, because it's what we consider a keystone species when it comes to climate change. Pikas live in basically a zone we call a Goldilocks zone of temperature and elevation. And with a warming climate, that zone is being pushed further up in elevation. But of course, the mountain can only go so high, right? So these populations are being pushed up, and we're concerned that with this warming climate, that the colder areas up top that warm are no longer suitable for pika populations. So they're letting us know how healthy our area is by basically where they are in that level of zone. We've noticed in some areas of the park that they're doing really well, in other areas they're not. So it's an active study. And again, I do have a link to that at the end of our presentation as well. So, we do a lot of research in Denali National Park, and probably the most forefront research we do that everyone's want to know about right now is obviously climate change. So we have these weather stations set up throughout the park. There's about 4 of them. They're part of a project called Vital Signs. So, it's pretty much the same concept as like going to see your doctor, right? Your doctor takes your vital signs, and then when you visit your doctor 6 months later or a year later, or whenever you do, they're going to do your vital signs again, and that's called trending, right? So they're looking at your records of medical history. Well, we're doing the same thing when it comes to Denali. We are tracking the medical history of the park and of the area that it resides in through these weather stations that record temperature, humidity, dew point. They even have a laser that will record snowfall. They will collect wind. They even will collect sometimes particulate matter. So if there's a major fire, it can record that information. And this is all public. And at the end, I have a link that'll show you right to the vital signs. Out of 418 national parks in the United States, or units, over 280 of them have stations just like this that you have access to see what kind of information they're getting. And this particular station is located at Eielson Visitor Center, which is where I primarily work and am stationed and live. So yes, that is my office view. I know it's hard to look at sometimes. It's sensory overload. The mountain in the background is indeed Denali. That's 20,310 feet. Much of the surrounding landscape is, incredibly gorgeous just as well. But that's the mountain that most folks come to see. This is a very rare day. It's not normal to have such a view, but I'm glad I can share it with you guys. Every day we do check these weather stations, and some days are not as gorgeous as others. The weather station records that information too. This is actually data from that station, or from the Denali station on the front end of the park, which has been operating since 1925. It's one of the longest recording weather stations in the state of Alaska. So as you can see, it's showing us this trend that really started in the 1970s, when it just started to take off, going warm, okay? So slowing down. And then the 1990s, Alaska in general saw some major spikes. This information goes only up to 2019, but 2020 and 2021 are on par to be where those red dots are. So we don't see any kind of slowing down or dipping. But it's a very big state, so there's a lot of research to get from, and you have to really go out in the field to find it, to look into it. So behind me is the Muldrow Glacier, and it's spilling out in between these mountains. I'm standing on a prime example of what the terrain looks like. There's permafrost beneath my feet and practically all around the alpine there. The glacier is moving at such a rapid rate right now that we've actually closed off much of the area that I would have been in, just because we're a little concerned about what it's doing to creeks and river crossings. But in a normal season, getting back there is a hurdle. I can't imagine what it's like now. But when you're back there, this is what you're greeted with when you see an Alaskan glacier. It's not that original image, right, of that tidal glacier. It looks dirty. It just doesn't have that same majestic appeal that you see on National Geographic. Some people have even come to me as a park ranger and expressed their disappointment in seeing this, which is incredible because the section of ice that's immediately in front of us is about 3.5 stories tall. It is incredibly thick. We're looking at roughly about 100 meters beneath our feet of ice, but it's covered in these rocks and taluses and dirt. And it's doing what a glacier does in the central heart of Alaska Range, is it's carving out the rocks, right? It's pulverizing these mountains that have been growing for millions of years, to carve its way to create an incredible, beautiful glacial valleys. It does have its challenges to get to these glaciers. As you can see, there's no trails. It's a very jaggedy landscape. These rocks are fresh, broken up, and how that basically works is, it's called a wedging system, or ice wedge. And we're going to talk a lot more about ice wedge and how it basically expands rocks and even the earth itself. When in the summer, the ice melts and water pools and collects in between cracks. And as it freezes come winter, that water expands into ice, right? Just like when you're making an ice cube at home, it kind of expands a little bit. And it breaks off that rock. And in some cases, as we're going to see later, it breaks open the ground. And it creates these jaggedy, ununiformed landscapes. Now, when we're up there looking at glaciers, would you believe me if I told you right now that you're actually looking at a glacier? And if you're looking at this glacier, where do you think it is? Can anyone take a guess on where this glacier is? Just feel free to type that in the Q&A. Bottom right? Yeah, you're right. Good eye there. So this is what we call a rock glacier. Again, it doesn't have that pretty physique that most of our other ice does that all the filmmakers want. So when people come up and they want to take a picture of a glacier, this isn't usually what they want to show on their social media. Yeah, that was a really good guess. So that lobe that you see down there is actually, there's ice underneath that. So there's jagged rocks that have come down on the ice and covered it, and it actually acts as an insulation. So it helps protect a lot of that ice from melt. The rocks themselves assist with reflecting light because they're a lighter color rock. Most of this rock that you're seeing here is a granite type. It's about a 50 million year old plutonic igneous granite. That's the similar kind of rock that you would find on Denali. So when rock breaks off a Denali onto a glacier, it adds that level of insulation and then also reflects it. So we're seeing some of that here in this rock glacier. And rock glaciers are critical water reserves for a lot of native species of fish, wildlife, but also humans. And we'll, at the end of the presentation, we'll talk about how rock glaciers are being critically studied in actually California right now, considering that they have a drought. And they have never really looked at rock glaciers. And they come up to Alaska and we tell them that, yeah, they're a glacier that holds copious amounts of water. And they're wanting to protect them just as much as a tidal glacier would be. This is a classic example of a rock glacier. You couldn't miss it. This is actually in Wrangell, St. Elias. Wrangell is a 13 million acre national park. It's the largest national park in the US. To give you a perspective of what 13 million acres is, Indiana, I believe, is roughly 32 million acres. So it would just be a little under half of Indiana if you declared that a national park. And in Wrangell, you see massive amounts of ice glaciers like this. Now, again, it doesn't look like there's a lot of ice there or water. But what's really neat is we set up a sound station, and I'm going to play it and hopefully it works for us. No, doesn't sound like there's any audio, unfortunately. Well, if the audio could play, what you would hear is a trickle of water. And it sounds like a creek or a stream of any other kind anywhere else, but beneath your feet. And that trickle of water is, feeding into some massive river valley areas and create these what we call braided streams or braided rivers. This is a typical scene in the state of Alaska landscape. This is a glacially fed river, and it doesn't flood the whole great area. What happens is this water just migrates, it moves, it creates these lovely braids back and forth, and then flows out into the ocean. But these wide open valleys are just inundated with gravel that sometimes can be several hundred feet thick, and that also can have permafrost underneath the river itself, and which poses an issue. And sometimes when we have hotter seasons, when we have more water and the water warms up and it percolates down to that permafrost and melts it. So we have a wide variety of landscape up here, right? We have these beautiful glaciers, we have these rock glaciers, we have these open valleys, and then we have the tundra, which is exactly what we're looking at right here. And tundra, you can actually find in the lower 48 in many places up in the Rockies. And there's even some spots, I believe, actually in northern Lake Superior area too, in the Midwest. So, but a lot of folks, they come up to this tundra and they take a step on it and it's spongy. It holds copious amounts of organic material. The top layer, which is just basically grasses and sedges, is a network of plant life that is intertwined through its root system and is basically a giant carpet. And it's very soft. So it's not uncommon for researchers who are tired from a long day to take a nap on this tundra. What is becoming unfortunate is the tundra carpet is actually tearing itself apart. And that's happening again due to climate change. We're seeing a warming temperature, and that's where permafrost plays into play here and causes these little slumps. Now, let's get into permafrost. I've been setting up the stage, and here we go. This is what is underneath your feet in that previous photo. You have that top layer, that top carpet, right? That insulating layer that's on top. And then right beneath that, you're greeted with an entirely different mixture of soil. and that's going to be your permafrost. And what we classify as permafrost is permanently frozen soil that's frozen for more than 2 consecutive years below a temperature of 30 degrees Fahrenheit or 0 degrees Celsius. And you notice that on top where that carpet is, that's considered an active layer. Now, an active layer actually will freeze in the winter and then thaw out in the summer. And that active layer fluctuates in some places, and it'll, gain ground on the permafrost. And in some areas, that active layer can actually slump off, just as it is in that other photo, exposing permafrost completely. Now, permafrost, as you can see, in some places, it looks more dirty than others, and then other areas we see more brown ice, and it's simply just called ice rich and then ice poor areas. Permafrost is a vast expanse. It covers vast areas of the park. That blue color tones on the northern end is what basically permafrost is beneath your feet there. Darker is going to be your continuous. That means it's permanently frozen. And then that lighter is discontinuous. So that means that permafrost can actually fluctuate, right? And that's an area that we're actively seeing growing, as we're seeing more and more of this discontinuous permafrost. And if you look south, you see a green, and it's labeled as none. So that's odd. There's no permafrost on that end of the Alaskan range. But if you see all that white is either rocks from the high mountains or it's glaciers. And there's very little permafrost up there. So to give you a lay of the land, the Alaskan range, which is where that white is, to the south of that range, it holds higher temperatures, more vegetation, and higher water content, and higher snow levels. And that snow acts as an insulation on the permafrost itself. And then warmer temperatures in the summer basically melts permafrost. So there's very little of it on the south range. But on the north range, there's very little snowfall. So the ambient air temperature that touches exposed rock or exposed soil freezes in a lot of cases. So there's more permafrost that's there, and it has been there since the last ice age came through, about roughly 10,000 years. But there's other areas of the park that has permafrost as old as 200,000 years. And we're getting incredible amount of data, and we'll talk a little bit about why these ages matters, because permafrost actually acts as a time capsule in its own sense. Now, when permafrost melts, which is what we're seeing a lot of, it inundates the soil and it floods a lot of areas, and especially in the vegetation such as these trees. So these trees, you see them bent over, right? And if you were in the Midwest and saw this, you would say, it's wind. It's got to be wind damage. But up in the Arctic and Alaska, I see these trees and I don't see wind. I see water. With more and more rapid thawing out of ice, we see forest areas look a lot like this, just kind of haphazard. The scientific term for these trees are drunken trees. They have drank too much water. Go home, tree. You have drank so much water, you're overhydrated. And this is posing some hazards for traveling through these woods. Wildlife also, do you think if you're a bird, you want to nest up there? It's not ideal. And right now, obviously, this is migrating bird season, and that's having a major impact on where birds are finding habitat on a wide scale. Now, permafrost also impacts humans, every day. Now, if I showed you this picture, I'm pretty sure some of you are like, I know that bridge, because it probably looks like somewhere in Indiana or Illinois or Minnesota. But no, this is up in Alaska, and this is just a glimpse of what kind of damage permafrost can do to the infrastructure. When you build a bridge back in the 60s, which is when this was constructed, you built it on permafrost thinking it would be permanently frozen ground. Well, due to melting, our bridges are tipping, cracking. In some places, they're literally just floating away or sinking into the soil, which is what's happening here on the right of this bridge. Now, really what brought our attention to infrastructure damage due to permafrost wasn't because of the drunken trees or, we do these studies often. It's because back in the 1990s, we did a survey of the park road, in Denali. And this is one of those benchmarks that was put in by the USGS, or at this time it was the General Land Office, along the road to mark the road. Now, my 2016, I was up here and we were looking for these benchmarks. And we knew there were 76 of them throughout the park road, which is about 92 miles long. And we start looking for these benchmarks and we realize that a lot of them are missing. They're just gone. And some of them are gone because of road construction and the others are gone because the entire road itself has migrated. So the GPS points that, or the measurement points that were put down for these benchmarks over the decades has shown that the ground itself is moving. One particular benchmark we recorded has data going back from the 1970s. In 2016, it had migrated on the surface due to land movement of melting permafrost, roughly over 175 feet. So it migrated to a point where over time, it's not noticeable to the eye, but continuous measurement, we see that the entire road is moving, and that causes maintenance and that causes severe damage as well. One particular area of the Denali Park Road that is kind of a problem due to permafrost melting is what place called the Pretty Rock Slide. Now, I have a link for this as well. This is an active slide in the park where permafrost is melting from underneath the road and causing it to move. Now, the road was built, like I said, in the 1930s. This movement really didn't start until the 1970s, and researchers noticed it, but it was minimal, right? It would maybe move like 2 or 3 inches a year, and that was it. Then in 2014, there was some kind of massive rain event that occurred, and the road started to move rapidly. And in 2014 to now, you see massive movements. The yellow dotted line is the original active slide that we thought was moving in 2016. And then the red dotted line is to show how the slide has expanded in 2018. So what we thought was that green elephant foot, that vegetation below where that red dot line is, where it meets the gravel bar, we thought that area was stable, like a buttress, when in reality, it started to move. And now it's displacing more rock above it. This road is a very critical link to tourism in the region. It's so critical that the two Alaskan senators has visited this site. Senator Murkowski came out and was given a tour by the Park Service, and the discussion of how do we fix this road to keep it open for not just Alaskans, but also for anybody to come and experience this place. It's a daunting engineering challenge. It's going to cost a lot of money, and it has yet to be resolved. But right now, the road is showing that it is not slowing down. This is the Pretty Rock Slide. That's a close-up look of the section. You'll notice that in 2018, that's your old road, but as you progress, you go to 2020, and that's the road from last year. And then there's a massive gap from where the 2020 road was to its original location. That gap is 29 feet. So remember I talked about how back in the 70s and 90s, the road would move maybe a couple inches a year. Just since November of last year to early April, when this photo was taken, the road has moved 29 feet. So it is an active slide. We've done core drillings. We're seeing that the permafrost is disappearing at a rapid rate. It is non-existent at a depth of 80 feet, when back in the 70s, it was existent at a depth of 9 feet. So we're seeing a rapid melt here that is causing the entire road to collapse. So this is the view from the road, and this is why a lot of people want to keep protecting it and keep opening it to make sure that folks from all over get to view this. Below is the Plains of Muir, and across you have the Alaskan Range. And tucked away in there are actually some glaciers that you can see if you look really hard in between the little valleys. There's some snow, which is glaciers, but lower beneath that, you see the glaciers are covered with rock, and they feed into these little creeks that go below through the Plains of Muir. And then if you look even closer on the plains themselves, you'll notice there's boulders, right? So there's little boulders here on the left, kind of in the sun. Those are called glacial erratics. right? So these glacial erratics were deposited about 20,000 years ago when there was a glacier that moved through this valley. The largest one you can see there to the center left on the screen, that erratic is 3 stories tall. You know, it's actually the size of an office building. Just to give you a perspective of scale on how powerful these glaciers can be. Now, what's going to happen now, right? So what's our future? We see, you know, these melting conditions. We see them impacting the state today. So we have these climate models that kind of predict, right? So this model was done in 2010, and if you look on, you see that there's a lot of Alaska in 2010 that was below freezing temperature when it came to the soil. It's predicted with continuous warming as of when in 2010 that we would see that permafrost and that melting of glaciers and soil temperatures rise. Unfortunately, this climate model is wrong. And I wanted to show it to you because we can do the science the best we can now. But as we progress in science, we realize that the conditions themselves are outpacing our knowledge. So in 2010, we thought this is what the future might hold, when in reality, we are closer to 2050 than you think. You know, in roughly in about 10 to 15 years, we might be looking like 2050, where that soil temperature might be ideal. In 2010, Denali had 18% ice cover. In 2020, that percentage dropped to 15. And to give you a perspective, 15% of ice cover in Denali, it would be about covering up the entire county of Cook County in Illinois. So imagine losing sections of Cook County almost every 10 years, massive sections to snow melt. And the depth of the permafrost we're talking about here isn't shallow. Permafrost is very thick underneath the ground. It can go anywhere from a couple inches on the southern end of the state to the north end where you see Burrow, the northern end of Alaska. The depth there can be 1,500 meters thick of permafrost. That's equivalent to basically putting the entire Sears Tower or the Willis Tower beneath the ground of frozen soil there. Other climate models, it's very important that we're studying these changes. So Denali is actually part of international studies too. This is an image from the European Space Agency. They have looked between 2003 and 2017 how permafrost and continuously frozen soil has retreated northward, right? When we look at this, we're looking at big picture, but we're going to focus on one small area. We're going to go to northern Scandinavia. So that's going to be northern Norway, northern Sweden. And you look in 2003 and you see that, you know, about 25% of that country, those countries in the northern hemisphere areas are covered in snow and permafrost. And then you transition to 2017 and you see that drop dramatically where now it's actually 5%. And if you look throughout this process, you'll notice there's a massive retreat all across the board. The northern hemisphere, about 25% of the landmass in 2003 was permanently frozen or continuously frozen permafrost in the area, and that is rapidly retreating. Now, why is this also another concern? Is because permafrost holds large organic material that once releases carbon, but what's also really concerning is methane. And methane is roughly 80 times more detrimental to a greenhouse gas than carbon is in the short term. And that can cause heating, which in turn heats the soil, which heats the permafrost, which causes it to melt, more melting, releasing more methane. What you have there is what's considered a feedback loop, right? Where you have this circle of continuous melting and continuous heating of rising, or temperature rising, which also heats the surrounding water, right? So looking at the North Pole, we don't really see a landmass in the center because it's consistently with ice. Well, that is also changing. The Northwest Passage is now becoming accessible because the disappearance of coastal ice is also exposing the shoreline to erosion. So a lot of communities that have lived on the coast there are being forced to move And the permafrost itself is breaking off into the ocean as even just gentle waves slightly erode at this material that's very easily degraded once it's exposed. Now, we're greeted with these monumental tasks, and it can be very overwhelming, especially when studying it. And this is the pre-slide slump area. The family photo you see there, that photo was taken in November of 2019. And you can see there's a little bit of crack starting to form. And that's where the slide has started right there. So it's the edge of the slide. And then you go to the other photo where the park geologist is, and he is standing on a slide that has slumped in March 9 feet. So in 5 months in that time period, the road has moved 9 feet. This is happening through all over the state. And it's very difficult for geologists to keep up with it. And it's very also difficult for even locals like the one we see here on the left for families to visit and travel and to experience this landscape. And it's even more concerning when it's happening in their backyard. So we talk about backyards. This particular slump actually happened not far from where I live. That is me standing there over there in the bushes looking at a section of tundra that has just broken away from a massive rain event. Now, rain does have a major impact in the continuous melting of the permafrost. It percolates to the soil. It's usually warmer water in the summer, and it activates. And once it hit ice, it doesn't necessarily freeze. It actually will thaw ice, and you'll see these massive landslides occur. And it, looking at it, you feel very daunted. You feel like it's like, how do you stop this? Like, this is a place that we've come to learn, to love, to visit, to see in our media. And when we see the land literally falling apart beneath our feet, we feel like there's a mountain on our shoulders. It seems like this imposing landscape that is just unbeatable. And it really, you can't fight nature, but we have an incredible responsibility to study it, to be part of it, to educate ourselves, to make sure that we make decisions knowing that our impacts are not just local, but also global. And we do that through encouraging folks to participate in their local research. When visitors come to Denali, we have a citizen sciences program where we have people engaging in a wide variety of active going research. This particular one, we have a couple of visitors that I took out in the field to collect bear poop. Yes, I said that. These folks are picking up bear poop. It's different from picking up poop like your dog at the park. What we're doing there is we're actually collecting bear poop, and then we're doing a DNA study, and we're figuring out how healthy are our bears. In these trying times, we're really concerned about them. And so were these people enough to pick up their poop a little bit. So it's a fun DNA project that's still ongoing. And with that, it's continuously challenged to live up here. But we love it, we appreciate it, and we always look forward to being able to share it to anybody. I would implore you folks to get engaged in your local community when it comes to climate change, activism and such. I would even encourage you to visit a glacier if you can. Those glaciers, as we all know, are receding and disappearing, and same with the permafrost and rock glaciers. So when you visit that glacier next year or the year to come, you're seeing something that the following folks will never see the same. You'll get an opportunity to experience what it's a glacier up front and close in our generation. And as generations come, your story might be passed down. And that importance of that story is beyond what we can measure today. So that's what I highly encourage you folks to do, is if you have the opportunity, find a glacier. There's plenty still out in Montana, I know are close. Alaska is a great place. There's glaciers, obviously in Northern Europe, still to be visited, New Zealand. And even if those are difficult to get to, casually walking to Lake Michigan and looking at the shelf ice. And when I was a young kid, that for me, that was the closest I thought I would ever get to a glacier. And it is still very similar to see that up here as well. So being educated is a key component. And I'd like to end on this final note of like, your local library has an continuous wealth of resources to look up more information if you're just interested to what Alaska has to offer, not just in climate change, but also as a cultural hub in our country. This is some books and materials that you folks might be interested in. The Molly of Denali is actually also a podcast for young kids, anywhere age from 3 to, I believe, 12. It also is a PBS show, animated. And Molly of Denali actually is based off of several Denali characters. And the national park up here works closely with PBS to ensure that, you know, the story of local Alaskans are being told and shared in a public way. Two in the Far North is a great book if in reference to the nature that Denali has to offer, or Alaska in general. Margaret Murray has an incredible rich history here. One Man's Wilderness is what it is indeed titled. It's about a guy who built a cabin in the woods. Nevada Bar on the far right is a mystery novel, and she writes specifically about mysteries in national parks. And again, Two Old Women is a great book to hear Native Alaskan voices and what it's like to live in a landscape that is changing and challenging in its own right. You know, so these are all at your fingertips. I highly encourage you to seek them out. These are some of those links I was talking about. And what I'd like to do now is I'd like to spend the next remaining 10 to 20 minutes taking your questions. Thank you guys so much for inviting me to talk to you and share with you some information. I know we could spend hours on it, and I'd like to see what you guys want to learn from me, or any questions about coming to the state or anything else. But again, thank you so much, and I appreciate it. Take care.
We have an attendant who raised their hand. I think they want to ask a question. I allowed Sandy to be able to talk.
Sure.
Sandy, I'm not sure if you meant to raise. Oh, did you put it in the Q&A? Okay, cool. Well, I see someone. Gabriella has a question. Saying, do you permanently live in Alaska at the park?
Yeah. So I do not permanently live in the park. The Toklat area, which is usually where I'm stationed for 6 months of the year, we close for the winter. The park itself is open year round, but only the front end of the park. I moved to Fairbanks come the winter and still stay closely in touch with the park through ongoing research and primarily education. But yes, I do usually live around Fairbanks year round, or live in Alaska year round.
Myself, I have a question about that. I have a friend who's currently in school studying to be a park ranger, and I was wondering, like, when it comes to getting a job as a park ranger, when like you find a park to work at, is it like a steady place, or do you have to like move around a bit when it comes to working as a park ranger, like at a national park or something?
Yeah, that's a really good question. You know, the ranger's life, we do move quite often sometimes. I've been at Denali for the last 5 years and very fortunate for that. Most of our rangers start off as interns in one way or another. So the Student Conservation Association is a great way for young teenagers to get involved in the National Park Service and then pursue an education related to that field. Once they're in college, they become eligible to work for the Park Service for part-time or for seasonals, either at their local park or any other park in the US. The National Park Service has roughly 22,000 employees. Most of them are seasonals. And we do have permanent rangers who are here year round. But for the most part, we prefer to stay in one park. I have decided to travel a little bit. So a little bit about my background is I actually started working as a ranger at Indiana Dunes National Lakeshore. So that's where I started my career, is on the beaches of the dunes, which now is classified as a national park. It was great to work there and see my neighbors every day and share an incredible place that I did not know was such an amazing, beautiful culturally area for Northwest Indiana. And then I worked in Yellowstone for 2 years, and I went to school at Utah State University, and I studied recreational resource management, which is basically why you recreate, with an emphasis in natural disasters, which hence climate change, and why glaciers became a major fascination for me. Yeah, does that help answer your question?
Yeah, I was just like wondering about that. I also have like one more question I wanted to ask. Like, what kind of questions do you like get? Do you get a lot of questions like being a park ranger? Like when people come to the park, do they ask you a lot of questions when they come through?
Yeah, it's really incredible to see how what's important to somebody to ask me. They see me in uniform. They see that classical ranger hat, which you can see is being represented if I were a park ranger, right? So like that uniform just stands out. It's a piece of Americana. It belongs in the landscape. People ask all sorts of fun stuff. They want to know where the wildlife are half the time, and I politely remind them that wildlife moves around. It doesn't have a particular schedule on when we could see them here or there. Folks want to know a lot about how do I get food, because when you come out to Toklat or Eielson, where I'm stationed, it's a jaunt. It's about a 2.5 hour to 3 hour ride from the front end of the park just to get there. So they want to know how I live in such a place. What they're getting at is, how do I keep sane? A lot of rangers love the outdoors. We're backpackers, we're hikers, we're bikers. We're actively engaged in our way of life and working with the research and working with the public. Folks also want to know a lot about the human history of the landscape. We've noticed a lot more folks really interested to see what is the connection between nature and humans through native culture and through different eyes and different perspectives and different stories. So folks have really garnered that as attention, and they realize that they are becoming part of those stories. So yeah, we get a wide variety of questions. I believe I could write a whole book about all of the unusual questions I've gotten from visitors.
By the way, thank you for answering that. I always kind of wondered. I've
Yeah,
never
great.
been to a national park. I've only been to like my local parks, and I've never run into a park ranger. So like, I never like really thought of like, I was like, what questions do they get? But I never like thought of it too much until my friend told me that he was majoring to be a park ranger. I was like, oh, okay. It was real. It's like really interesting. I don't want to like lose this person's questions. Let me ask it. It's from an anonymous attendee. Uh, they said, I don't know if you touched on some of this, but do you have any recommendations for a college senior biology major looking to find a career in the parks?
Yeah. So first off, you're in a really good field. Biology is a key component. We hire a lot of folks that look after wildlife in the park. So we call them wildlife technicians. We have an entire division in every national park that I know, and that division is called resource management, and they're full of biologists, geologists, every scientist you can imagine are in that division. And they're focused primarily on the resource itself. So when it comes to careers, and if you're a biology student, if you're interested in plant life, Denali is a really good place. We have one of the longest going plant life surveys systems in the state of Alaska. And it's led by several rangers I know that have been out in the project for decades. If you're interested in wildlife, there's some really good rangers, wildlife technicians that work in the park, not just in Denali, but in other parks. And their primary task is basically studying the wildlife. Most of them have some kind of wildlife biology degree. And those studies, I mean, they go everything from, your job encompasses everything from telling folks to stay away from the bears, to working with researchers to tag, to track wolves in Denali, and then even caribou and elk in other national parks, and looking at their bone growth for their antlers, which is the fastest growing bone structures on the planet. And right now is being studied by several medical institutions throughout the world to see if they can implement bone growth on elk and caribou and moose and incorporate that into the human physiology. So, I mean, the biology there is sounds like Star Trek and sci-fi, but it's a tangible thing that as a biologist, you would work with such folks, and you would help such researchers make sure that they are, getting what kind of studies they can get done. If you're still in college, I would recommend, reaching out to your local national park. Let them know, hey, I'm studying biology. I'm really interested in what you do here, and talk to them. They're willing to work with you to see what fits for you. And then hopefully you can start your career that way. A lot of times, like I said, college students start off as interns, and then very quickly get picked up into the park service. So good luck.
Believe those are all the questions. Oh, also, Linda made a comment saying that it was a really great presentation, and thank you.
Oh, thanks, Linda.
And I also wanted to thank you for the presentation. It was super interesting. I honestly don't know much about Alaska, and so this was a lot of information and very useful information. It's like super cool, and it's really nice to like learn about like a state that's not encompassing Illinois, because that's usually what we touch on. And it's nice to just learn about the other states and the nature that's around it. And thank you so much for this information that you have provided for us this Earth Day. Thank you so much. And thank you to the audience for coming out. And I hope you guys also had a really good time. And I hope you guys had a really good Earth Day.
Well, thank you very much. It's a pleasure.
for another presentation. And if you guys have any further questions on the program, you can email me and I can email the questions over to Nick. And you can reach me at the outreach at orlandparkpubliclibrary.org. So thank you, everyone, and have a good night.